Hello students, let us begin with another important chapter, surface area and volume. In this chapter, we shall take up the solid figures and we shall discuss surface areas of those solid figures and then move on to the volume of those solid figures. Along with the previous knowledge, we have got one more solid figure by name frustum. We shall do that at the end. Let me take up the solid figures right from cuboid. First we will discuss the surface areas of all the figures. We will begin with a cuboid. What is a cuboid? Cuboid is a three-dimensional figure or a solid figure which has got 6 regular faces. It has got 6 faces. Each of the face is a rectangle. Each face is rectangle. Since each of the faces is rectangle, the angle which is formed at its corners will be 90 degree. It has got 8 vertices and 12 edges. The opposite faces of a cuboid are always equal to each other. It means that the opposite faces of a cuboid are in the same dimension. The measures of the sides is called as total surface area if you consider all the sides. If you exclude the base, there will be 2 bases. Those bases are excluded. We get the lateral surface area. So we have got the concept of the surface area like total surface area, which is usually mentioned as TSA, and lateral surface area, which is mentioned as LSA. Before going into the concept of area, let us denote the dimension of a cuboid, which are length, width, or the depth. Actually, it has to be width or the breadth, and the height by length as L, W with respect to width, and H with respect to height. Then the total surface area is given by 2 times of LW plus WH plus LH square units. Most of the time, instead of W, they may also use B representing the breadth. LB plus BH plus LH square units. And the lateral surface area is 2 times of LH plus WH, or if 2 H is taken common, we'll be getting L plus W square units. For the convenience, I'll take B as the breadth. Let us find out the cuboid's surface area in terms of length L, breadth B, and height H. Surface area of a cuboid is equal to sum of all the areas of 6 rectangular faces. Let's consider a cuboid. In this cuboid, the total surface area is sum of all 6 faces area. So 2 times of LB BH, 2 times of BH, 2 times of LH. If 2 is taken common, we get LB plus BH plus LH. Here, why did I consider 2 times of LB? Length into breadth will give the area of this surface EFGH and one more ABCD. So 2 times is taken. Now the lateral surface area is the area of all the sides apart from the top and bottom faces. These top and bottom faces, they are also called as the bases. The top one is called as upper base and the bottom one is called as a lower base. Lateral surface area of a cuboid is area of the face AEHD plus the area of the face BFGC plus the area of the face ABFE plus area of the face DHGC. So lateral surface area of cuboid is 2 times of BH plus 2 times of LH. We get 2 times of H multiplied to L plus B. If you can remember, in class 9th we had a question, what would be the maximum length of the rod which can be placed in a cuboid of dimension LBH? The answer for that was root of L square plus B square plus H square. So you have to remember this formula. A diagonal of a cuboid is given by square root of L square plus B square plus H square. To recall the formulas how we had used, let's solve one or two questions. First question here is given below is a cuboid having its dimensions given by length equal to 6 cm, width equal to 6 cm, height equal to 5 cm. Find total surface area of cuboid. So total surface area of a cuboid is given by the formula 2 times LW plus WH plus HL. So 2 times of length into width will be 8 times of 6 plus width into height will be 6 times 5 plus H into L will be 8 times of 5. So 2 times of 48 added to 30 added to 40. We get it as 2 times of 118, that is nothing but 236. Therefore, total surface area of the cuboid is 236 square centimeter. Sometimes they ask the question like this. The dimension of a cuboid are as follows. Length is 4.8 centimeter, width is 3.4 centimeter, height is 7.2 centimeter. Find the total surface area and also the lateral surface area. So first, let me make use of the formula which we have learned. Total surface area is given by 2 times of LW plus WH plus HL, which is 2 times the length into width will be 4.8 multiplied to 3.4 plus 3.4 multiplied to 7.2 plus 7.2 multiplied to 4.8. So these multiplication are to be done first, then we have to do the addition. That you should not forget. So 2 times 16.32 plus 24.48 plus 34.56. The sum of this will be 75.36. This has to be multiplied by 2. We get it as 150.72 centimeter square. This is about the total surface area. Now to find the lateral surface area, we should consider only 2 times of h multiplied to L plus W. Here L into B part, which are the bases, are excluded off. So 2 times h is 7.2 multiplied to the sum of 4.8 plus 3.4. 2 times of 7.2 is 14.4. It has to be multiplied with the sum. Sum is 8.2. We get it as 118.08 centimeter square. So the total surface area is 150.72 centimeter square and the lateral surface area is 118.08 centimeter square. Let's take up another solid figure which we had learned, which is cube. The definition of surface area of a given cube states that if the total surface area is equal to the sum of all the sides, all the 6 sides. Since cube has got the 6 sides, therefore the total surface area will be 6 times area of one face, and all these faces, all the 6 faces are identical. All the 6 faces will be square. In the cuboid it was rectangle, so area of one face will be side into side. Here the side is given by A, so A square will be area of one face. So area of 6 faces will be 6 times A square. So area of the 6 faces will be the total surface area, which is 6A square. In other words, I can say that this particular cube is a cuboid wherein the length will be A units, breadth will be A units, and the height also will be A units. If you use the formula of cuboid here, cuboid's total surface area was 2 times LB plus BH plus LH. If you use that formula, it is 2 times A into A plus A into A plus A into A. We get it as 2 times of 3A square, which is 6A square. Say a cuboid and cube, they are interrelated. Cube is a cuboid with all the dimensions equal. A cube can be a cuboid but not the vice versa. Suppose if they given a question, the area, if area is given and side is asked for finding, you have to make use of formula A by 6 as side square. So the side will be root of A by 6. This is how we can find edge of a cube. If they ask you what should be the maximum length, or if they ask you the diagonal, how do we find that? In the cuboid we had a formula L square plus B square plus H square, root of L square plus B square plus H square. So we get root of A square plus A square plus A square, which will be root 3 times A. Root 3 times A will give the diagonal of a cube. Let us solve 1 or 2 questions related to cube. Calculate the cost required to paint an aquarium which is in cube shape, having an edge of length 10 10 meters, if the painting cost is Indian rupees, INR means Indian rupees, 3 per meter square. So here we need to find out the total surface area of aquarium. The total surface area of aquarium is 6 times of side square. Here the side is given as 10 meters, so we have to consider 10 square. We get 600 square meters. Therefore, the cost of painting will be, it is rupees 3 per meter square. This has to be multiplied with 600 meter square. Meter square will get cancelled. You'll be getting rupees 1800. One more question. If the side wall of a cubic structure have length 7 meter, find the total surface area. Given is the length of the side wall, which is 7 meter. So the side is 7 meter. The total surface area will be equal to 6 times side square. So 6 times of 7 into 7 will be getting 294 square meter. One more question. Find the length of edge of a cube and its area is given by 2400 square meter. So area is mentioned as 2400 centimeter square centimeter, not square meter, square centimeter. We know that length of edge is given by root of a upon 6. So it is root of 2400 upon 6, which will be root 400. This will be equal to 20 centimeter. So the cube will have each of its edge equal to 20 centimeter. Let us discuss the next solid figure, which is cylinder. The surface area of a cylinder is the area occupied by its surface in three-dimensional space. A cylinder is a three-dimensional structure having a circular base. The bases are circles which are parallel to each other. These two circles, they are parallel to each other. Do you find any vertices here? No, it doesn't have any vertices. Generally, the area of three-dimensional shape refers to the surface area. The surface area is represented in terms of square units. For example, centimeter square, meter square, so on. So a solid figure, a solid cylinder, we have to find its curved surface area and the area of the bases. So to find the total surface area, we need to find the curved surface area plus area of bases. Area of bases. How do we find curved surface area of a cylinder? If you cut the cylinder and spread over, we will be getting a rectangular sheet. For this rectangular sheet, the length will become 2 pi r and the height will remain same. H will be the height, it will remain same. So length and breadth will be h and length will be 2 pi r. So the curved surface area of a cylinder is given by length into breadth. Here the length is 2 pi r and the breadth is h. So 2 pi rh will give curved surface area. What about the base? The the base is circular, so pi r square will give area of the base. Now the total surface area will be equal to the curved surface area 2 pi rh plus area of two bases, so 2 times of pi r square. Observe here, both are having 2 pi r common, so 2 pi r if you take common, we get h plus r. For convenience, we always prefer writing 2 pi r into r plus h because it is easy to remember it like this. It comes in a flow, 2 pi r into r plus h. In most of the questions, we make use of pi as 22 by 7 or 3.14 for calculation purposes. Look at this figure. A cylinder is cut off and spread as a rectangle. So this rectangle will be having 2 pi r into, or else pi into d as its length. This will become the length, and this part will become the breadth. Here you observe pi r square and pi r square. These are the bases. This one is a lower base, this is upper base. So when we consider the total surface area, we need to consider these two bases along with the curved surface area. Here, since the lateral surface is curved, we prefer saying it has a curved surface area. So once again I will tell the total surface area is given by the curved surface area plus area of two bases. The curved surface area is length into breadth, it is 2 pi r h plus area of the two bases, it's 2 pi r square. 2 pi r taken common, we get r plus 2 pi r into r plus h. If the question is to calculate the cost required to paint a container which is in the shape of a right circular cylinder having a base radius 7 meters and the height 13 meter, if the cost of painting the container is Indian rupees 2.5 per meter square, take pi is equal to 23 by 7. Here the total surface area is given by 2 pi r into r plus h. Here 2 into 22 by 7 into, they have given the radius as 7 and the height as 13. So 7 will get cancelled. We'll be getting 2 multiplied to 22 multiplied to 20, which is 880 meters square. Therefore, cost of painting will be equal to it is rupees 2.5 per meter square multiplied to 880 meters square. This meter square cancelled, rupees 2200. Second question, find the total surface area of the container in cylindrical shape whose diameter is 28 centimeter and height is 15 centimeter. Diameter is given as 28 centimeter, so the radius will be 14 centimeter. Now we can find the total surface area, which is 2 pi r into r plus h. They have mentioned the height as 15 centimeter. So 2 multiplied to, I'll take 22 by 7 because the radius is 14, can be simplified. So 14 plus 15 is r plus h, 7 2 times. So we get it as 2 multiplied to 22 multiplied to 2 multiplied to 29. This will be equal to 2552 centimeters square. We shall take up cone and sphere, and we shall discuss surface area of cone and sphere in the next session, followed by volume of all the solid figures which we have learnt so far. That's all for today's session. Thank you.